Hi, in this particular lecture, I want to talk about again about digital processing of analog signals. This is a topic that we have revisited in week two after having introduced in week one, and now in the start of week three, I want to talk about it a little bit more before we talk about actually digital processing itself. So, uh, we've already said that the processing um, system for analog signals, if you want to process them in digital, would look like this, right? You start off with an analog signal, you use an ADC to convert the signal into digital domain, and in the digital domain, you have the microcontroller, which does whatever processing you want it to do. And we're going to be talking a little bit about what kind of processing and how we can decide what kind of processing happens in the microcontroller. And then the digital signal may be converted into an analog output if you need that, right? Uh, what I wanted to emphasize here is what we mean by a digital signal. So, what do we mean when we say an analog signal has been converted into a digital signal? So, what does a digital signal actually look like? So, one of the things that uh, I'm not sure whether you have appreciated as we have done analog to digital converters and digital to analog converters is the fact that when we say digital signal, what we mean is basically an array of numbers, right? What we are saying is that we have an array of numbers, and let me just write some variables here. So A naught, A1, A2, A3, so on, right? So this array of numbers is what we mean by a digital signal. Another way to think about this array of numbers is that they are samples at different time instants of the analog signal. So if we had an analog signal here, let's just say the signal looks like this. Okay, so we take samples of this signal at different time instants, right? And these samples, these points, these values that we have become the digital signal, which are these values. Okay, in a digital signal, essentially, you don't have any time information other than the fact that you know that, for example, if you're doing uniform sampling, that is, if the sampling interval is, let's say, TS and it's TS all over the signal, then what we are saying is wherever A naught was sampled from, A1 has come TS seconds after A naught, and so on and so forth. But if you really look at the digital signal itself, the array of values that you have, there is no time signature in that array of values. At a different location, you might have stored TS, or you might know that your some signal has been sampled at, let's say, 100 hertz or something, right? So, so your digital signal basically is an array of numbers, and the processing that happens in the digital domain is basically trying to combine and do something with these array of numbers. And somehow processing this array of numbers is actually processing the signal that we started off. I mean, in some vague sense, you can see that that would be true. For example, if I take the average of all the values here, I'll get the mean of the signal. And that would be, you can see that very easily, right? But how would combining these signals in some form make, let's say, a filter or do some other functions? So those are the kinds of questions that we want to ask in this particular unit and get the tools for to actually uh, understand and develop these kinds of processings in a microcontroller.